doze off, don't worry. I'm recording this, so you can check out the YouTube later. All right, boys and girls, let's start it off. Where are we at? So we copied this down yesterday. I just want to confirm.
Yeah.
Yeah, so let's actually use what we copied down. So we're going to go right to the next page. We have the absolute value of 2 plus 2. So this is your baseline, and then something when you put a negative in front and see how that changes. So let's talk about this one first. I'll do it in black.
Mr. Tobal.
Yeah, what's up, Leah?
Yesterday on the homework, when I was doing like the ones where they like widen or like shrink, do I like just take a guess on how much they shrink or widen?
No, it's proportional to whatever you wrote. So let's say if it's 2, or let's say 3, I just wrote 3. 3 and absolute value of 3, let's say like this. Then you could say it gets stretched by a factor of 3. So it's based off the number here. And then if it's 1 over 3, it's based off the fraction. So it's shrunk, or what's the word what do we use? Not stretch and shrink. What is it? Yeah, it shrinks. It shrinks by 1/3. So it's just whatever number's in front.
Would you be able to show that in like a chart?
Yeah, we'll do that on the next one, okay?
Also, would we have to like draw it out, or we can just write like it shrinks how many numbers?
The questions will be particular if I want you to graph, or if I just want you to tell me what they are. Like I'll just show you like 2 pages ahead. This one, you would just tell me what the transformations are. So you don't need to graph it.
Okay, thank you.
No problem. Okay, so we have the absolute value of 2. Just remember, and this is what you need to learn, the absolute value is like that straight up V. So right now we have a vertical shift of 2. So we're gonna go up 2 here, and then I'll make my V shape like this. And if I were just to make a table real quick, let's do -2 to 2. Again, the table's not necessary. It's just me trying to help and showing what is occurring. Then your Y values.
Mr. Tobal, I think that's telling us something.
That's telling us to start.
Thanks for teaching us that, Mr. Tobal.
So 4, because -2, absolute value would be +2. 2 plus 2 is 4. 3, 2, 3, 4. So we add up like that. Red on the other hand. So I'll make the table first this time. So in this case, I have a negative of the absolute value of -2, which means this would be a 0, because -2 plus 2 is 0. -1 of the absolute value of -1, which would be +1, but then negative is -1. -1 plus 2 is 1. 0 plus 2 is 2. -1 plus 1 is 1. 0 is 0. So you will have a flip like this. So this matches what we said earlier. If this value right here that's being multiplied to the function is negative, it's going to do a vertical shift. Now, if it was inside the variable like this, or in the function, it would do a horizontal shift. The issue is, and the reason why I didn't put it in this one, is that the horizontal the horizontal flip of the absolute value is still the same thing. It looks exactly the same. So it's not really portrayed here, but just remember, if it's inside the function, it's going to be a horizontal flip. Outside the function, it is a vertical flip.
What is the slope of these lines, and how would I find that
out? The slope, if you wanted to find the slope, you could just check it here.
Got it.
Rise over run. But for our absolute value, typically, it's going to be whatever is the value in front of this. So in this case, it will be 1. In this case, it will be -1 when you're going.
Got it.
So like, I'll show you that in the next one. That'll be more portrayed. Anyone else, any questions on this part? This is just vertical shifts being portrayed. Next, we're going to do the vertical shrinks and expansions. Shrinks and stretches. All right. Next one, shrinks and expansions. So here we have 2 absolute value. So I'll make a table again. This one will be in black. -2, -1, 0, 1, 2. The absolute value of -2 times 2 would be +4. Absolute value of -1 times 2 is 2, 0, 2, 4. So notice here, it's going up faster than our previous one if it was like a normal absolute value, which would look kind of like this. It's definitely getting up faster. So we're going to talk about that as it's vertically rising faster. Go ahead, Sammy.
Wait a minute. The 2, does that affect where it's placed at all? Because I was a little confused with the homework if like the number like outside of that affects where the graph should be placed.
So the 2 in front affects 2 things. It affects if it gets flipped or not. Since it's positive, it doesn't get flipped. And since this is bigger than 1, that means it's going to get stretched vertically, which means it's going to go up faster. Versus the other reason, it will go flatter. It does not affect any shifts left to right or up and down.
Okay, thank you.
So you can draw it however, you just have to make sure it looks steeper.
Or yeah.
Like to draw it at a certain like 2 or.
Yeah, it should be clear that this is a sharper. Now, typically on these type of questions, I would ask you to graph 2 things compared to each other. While this one, like I said earlier, you just tell me what's happening to it. Next one, I'll do in red. It's a half of the absolute value function. So in this one, it's raising slower. Because it raises slower, it takes longer to go up. So it's kind of getting flattened or shrunken or wider, however you want to use the verbiage. So half of +2 would be a 1, 0.5, 0, 0.5, 1. A little bit flatter, or quite a bit flatter, I should say, in that sense. It's going up slower, so the slope is less steep. The slope in this case, though, would simply be a half. That's not necessarily true for every situation, but because these are flat lines, it's easy to tell the slope is a half. When you have a parabola, the slope changes depending on where you are.
It's a half of x, like it's not a half of x squared.
It's a half of the absolute value of x. So whatever x is, turn positive.
Oh, and I was just like comparing this to the parabolas by mistake.
Yeah, that's fine. A parabola, if it was like a half x squared, it'll be half of whatever x is squared.
Yeah, I was just confusing them.
No problem. Okay. Anyone has any questions on this particularly? Or needs me to hold it on the page for like a minute more? Okay, so I'm going to the next page. So looking at A, I'm going to have to describe the transformations. We can kind of see that the base is x cubed. Doesn't really matter what your base is, the transformation rules say the same, but just pointing out the base would be x cubed, your parent function, you would call it. So right here, I see a negative being multiplied to my function. So I automatically know because it's negative, it's going to have a vertical flip. So one aspect that I have to talk about is that it's vertically flipped or vertical flip. You can say vertical reflection too. Here we have on the inside of the function -2. You kind of have to think of it in vertex form. Remember, it's negative h, so it's the reverse of what you're expecting. So since you're going -2, you're actually going right 2. So this is right 2. I should say shifted right 2. And then I have this 1 on the outside of the function. Those are vertical shifts. So the 1 on the outside means it's going to shift up 1. So it shifts up 1. For b here, you can say your parent function is square root of x. What's happening here is the half. Because it's a half and it's less than 1, it's getting shrunk. So it's a vertical, I should say shrink of a half, or by the ratio half, or by a ratio 2, depending on how you want to say it. Also, inside the function, there's a +2. Remember, inside the function, you have to think it kind of reverse. So it's going to be shifting to the left 2. Everyone, try number 4 by yourself, or C by yourself. What is the stretches or the shrinks or the shifts are happening here? I'll give it, I could actually just look at the digital clock, 30 seconds. Okay.
Should we type it in the chat?
Not right now, no, because
Okay.
it's too much to type. I'm just going to give you the answer. So this is going to be a vertical stretch because it's getting bigger. Stretch. Oh, God. I don't know how to spell. By a factor of 4. So you could say of 4. It's a -2 on the inside. So it's a shift, not to the left, but the right. So shift right 2. And the -5, it's going to shift down 5. Okay, and You don't have to tell me, but the parent function, I'm just pointing it out for you guys, is absolute value of x. You don't have to point that out. Anyone has any questions on that? Any concerns for it? It should be pretty straightforward. Only thing is a bit annoying is graphing, but inherently graphing is annoying. So nothing we could change there. Okay, so now we're ready for our actual section today. 1.4, combinations of functions. So I want you to write that down. Also write down the arithmetic combinations. They're very straightforward. You got a plus sign, that means you got to add the functions. You got a minus sign, you got to minus the functions. You got a multiplication sign, you got to multiply the functions. You got a division sign, you got a division function. Quick note, in this case, g of x cannot be 0 because you can't divide by 0. Slight note for the division one. Otherwise, everything else is okay. But it's very straightforward. You add them, or you subtract them, or you multiply them, or divide them. No tricks in this one, at least right now. So I'll give you a couple of minutes to write that. Nate?
What about if it's something like minus x or plus x instead of or divided by x? That in the first section, f of x, f of g, f plus g, and then minus root x, like that, minus x.
And then it's like negative x?
Yeah.
Then you have to plug in a negative x into what f of g is. So you'll see how we're going to make it, and then we're going to see how you can manipulate it. Because this is like a manipulation. This tells us how we make it, and this is how we're going to use it effectively.
Got it.
Okay. Anyone still need writing this down? I'm ready to go to the next page. I just want to make sure you are. Okay. So copy this down. This is your f of x and g of x. We'll use this for all 4 problems here. So we'll copy down the f of x and g of x. We're about to use it for all 4 problems.
Also, Mr. Tobal, what is our test? Is it our test on 1 to 1.5 on Thursday?
Yeah, it'll be up to 1.5.
Got it.
If maybe more, I don't know how far we got, but at least 1.5. I'll say that.
Do we see you? When's the next time we see you? I'll check.
Wait, do we have homework on this?
That's class tomorrow.
Yeah, that'd be a good idea. Yeah, I'll give you homework on this.
We have you tomorrow and Friday.
No.
Tomorrow? All right, then tomorrow.
Friday.
And Friday? Yeah, we meet a lot then. First period, wait, and then we meet Monday too, don't we?
Yeah, that's why we think we should be able to stop here, then we'll pick it up next time.
Yeah,
Definitely gonna stop here, maybe stop at the next section, but not.
yeah.
After question 1, I agree.
After when I say
if we legitimately have you 50 minutes for the next 3 more times? Like,
Then we
Like,
good.
do it-
We're practiced. We'll have all it locked down, and then next week it could be review all the way up to the test.
Well, like,
Math is awesome and all, but it's a little much.
if you do
I
the
hear you.
math, it's like the 50-minute periods are worth like 2 periods are worth 3 of our regular periods. So we're already ahead of the game.
Yeah, I think we should have homework time built into the class.
Math right there.
Oh, that's a great idea there, Lexi. Well said.
Lexi, well,
Fire idea.
Yeah, way to be.
Okay, that's actually a good idea with the homework time. I'll think about that. All right. So f plus g of x. This is the same thing as saying f of x plus g of x. So I can replace this f of x g of x with the actual equations. X squared minus 9 plus x plus 3. In this scenario, we're going to combine some like terms. X has no like terms, or x squared doesn't have any like terms. Negative 9 matches with 3 here. So I'll combine that to negative 6. And then x here doesn't have any like terms, so plus x. You could factor it, but I didn't ask you to do that, so you're done there. Just combine like terms as best you can. Now this one, I think, Nate, this is kind of your question, but how do you have something other than x, basically? So we can rewrite this as f of 6 minus f of, or g of x. F of 6 minus g of 6. So in this case, every x that I see is going to be replaced with 6 in this case. So it's 6 squared minus 9 minus, because this was minus, 6 plus 3. Every instance of x gets replaced with whatever in here. In this case was 6. So over here, 36 minus 9 is 27 minus 9 plus 3, which is 9, or 6 plus 3 equals 9. 27 minus 9 is going to be 18. This one, fg of x, same thing as saying f of x times g of x. So it's the same thing as saying x squared minus 9 times x plus 3. Remember, in these scenarios, you're going to actually FOIL it out. So if you FOIL it out, x cubed plus 3x squared minus 9x minus 9, 18, 27. Circle that, and that. And then the last one here. This is the same thing as f of 5 divided by g of 5. Every instant of x becomes 5. 5 squared minus 9 over over 5 plus 3. 25 minus 9, 16 over 8. Reduce that, 2. So for these, we're simply just plugging it in and simplifying. Very straightforward in this sense. Does anyone have any questions on this? All right, let's go to the next page. composition functions. This is our next section. So this is like the Russian nesting of a function, where you have a function within a function. So sometimes it's written like this. I usually like writing like that. Be used to this one on the right there. So f of g of x. So that means the function g of x is in f of x. And usually the symbol they use is like a hollow bullet point. So f of g of x is how you would pronounce it. F of g of x. So it's a function within a function. So how do we actually use it? Same functions as last time, so no need to change. Let's talk about number 5. F of g of x. This is the same thing as saying f of g of x. Now, as I said before, anything on the inside of the function has to be replaced with exactly what it is. And g of x is exactly x plus 3. So I'm going to rewrite this as f of x plus 3, because g of x is x plus 3. Now over here, every instance of x gets replaced with x plus 3. So I'm going to replace this. It's going to become x plus 3 whole thing squared minus 9. Because I have to replace the x completely with the x plus 3. Here, I'm going to FOIL out. Please don't assume